This is the 2020 projectiles question. Question 3. A particle projected from a point P, speed u, angle alpha, show that the range is this guy here. So let's just do a little diagram. Point P on the horizontal, fired up in this direction, u meters per second, at an angle alpha to the horizontal, and the range is along here. We'll call this one PQ. So the range is S of x, which is equal to PQ, which is equal to UT. My initial vector is going to be u, speed by the cos of the angle in the I direction, plus u times the sine of the angle in the j direction. So for S of x, my u is u cos alpha, so u cos alpha times t is the range. So you can see here we need t. So this is where we go to displacement in the y direction at this point equals 0. So that's my ut plus a half at squared. A being minus g as the particle is being brought down to earth. So we have u sine alpha for my initial velocity times t, and this is going to become minus g over 2, a half a, times t squared, and we can say that that's equal to 0 at the point Q and the point P. So factoring out my t, I get u sine alpha minus gt over 2 inside the bracket and t outside the bracket. My initial time equal to 0, this is at P, and u sine alpha equals gt over 2, so 2u sine alpha divided by g is the time taken to get to Q. So if we sub time into displacement in the x direction, we're going to get u cos a times t, which is 2u sine a over g. And tidying this up, we get 2u squared sine a cos a over g. So that's part 1. Part 2, the particle is 24.5 meters above the horizontal when t is equal to 5, and it strikes the ground 235.2 from P. Okay, let's do a little diagram. Projectile fired, and here's its range. Its range is 235.2. This is S of x. We're told the height at a certain moment. Just do a line across. It's going to be 2 times when the height's the same. The height is 24.5 when t is equal to 5. T is equal to 5. 24.5 is equal to the displacement in the y direction. So we've got sine, cos, and u, so we can get sine over cos and change it into tan. It might help us. So let's see, let's use S of x first. This guy is equal to 2u squared sine a cos a over g, or 9.8. So we can multiply by 9.8 and divide by 2. We're going to get u squared sine a cos a is equal to 1152.45. So we can get this in terms of sine, cos, and we have u, so we just leave it like that for now. Let's look at displacement in y. S of y is 24.5, so ut plus a half at squared. So let me just double check here our u sine a, just to confirm our y direction. U sine a times t which is equal to 5 minus a half at squared, so minus 4.9 by t squared, which is 25, is equal to, when t is equal to 5, we were told it was equal to 24.5. So we're going to get 5u sine a minus 122.5 is equal to 24.5. So 5u sine A is equal to 24.5 plus the 122.5, so actually 147. So there we have what u sine A is. U sine A is equal to 147 divided by 5, 29.4. If we could get a value for u cos A, we would be able to divide them by each other, and we would have tan A. Then we'd be able to find A. So let's see, this is the same as u sine A, u cos A. So we could say that u sine A is equal to 1152.45 divided by u cos A. So we can change the u sine A to 29.4. So this guy becomes 29.4. 29.4 equals 1152.45 divided by u cos A. So u cos A is going to be equal to 1152.45 divided by 29.4, given a value of 39.2. So we have u sine A and we have u cos A. So we can definitely get this down to one variable. U sine A over u cos A is going to be 29.4 over 39.2. And the u's will now cancel, leaving sine A over cos A, which is tan A. So tan A is going to be, just get the answer and get the inverse of it. So actually I'll use the decimal first. Works out exactly. It's 3 over 4. So what we're looking for u here, I think, aren't we? So that would give, we can then say what sine A and cos A are. A, just don't make a mistake at this point, tan A is opposite over adjacent. So cos A is 4 over 5 and sine A is 3 over 5. So we want u sine A is 29.4, so u times 3 over 5 is equal to 29.4. So u is equal to 5 times 29.4 divided by 3, which gives an answer of exactly 49 meters per second.